Okay, so number 1. I went ahead and took the 216, which was a perfect cubic, and I wrote it as 6 cubed. That's 216. You have to memorize that. Okay, then that's being raised to a 1/3. And now to get your final answer, you just apply the rules of exponents. So when you have a power raised to a power, you're supposed to multiply those. So 3 times 1/3 is just 1. So the answer would be 6. Number 1, the answer is 6. That's it. Number 2, let's rewrite the bases as prime numbers or as a 6. 5 is already a prime number. That's good to go. 125, however, that needs to be written as 5 to the 3rd. And now remember, it's being raised to a half. So when you see 125, you want to write that as 5 to the 3rd. Again, that's another cubic. Memorize it and recognize it. So number 2, I have, let me rewrite the question. I have 5 to the 1/4 times 5 to the 3 times a half. You multiply that. So that would be 3/2. And now you can do your answer by applying the rules of exponents. So when you multiply your variables like that or your bases like that, you're supposed to add the exponent. The base will remain the same. You don't multiply 5 and 5. Those are bases. Just keep it as 5. And now do 1/4 plus 3/2. And in case you forgot how to add fractions, you're supposed to find a common denominator between the 1/4 and the 5 and the 3/2. So I'm going to change the 3/2 to 6/4. So my final answer should be 5 raised to the 7/4. And then we can just keep practicing these. If you have a question, either raise your hand or talk to me. Number 3, this is just apply the rules of exponents, I guess. When you're multiplying variables like that, you need to add the exponent. So here, I'm just going to go ahead and add the square root of 3 plus the 1 square root of, plus the square root of 12. So you need to add the exponents and then always make sure that that it's simplified or that you don't have any like terms. So right now, it looks like there's no like terms, but I feel like the square root of 12 here for sure needs to be simplified. So let's simplify the square root of 12 and then see if I can combine it with the square root of 3. It's probably, so let me rewrite the square root of 12 as 4 times 3, so 2 root 3. So I rewrote square root of 12 became 2 square root of 3. And now I see that I can go ahead and add the 2 square root of 3 plus the 1 square root of 3. So final answer should be x raised to the 3 square root of 3 plus 1. The order doesn't matter. It looks like that. So I guess let's keep working these. Yeah, let's keep working. Number 4, rewrite it as prime numbers. It's going to be best if you just rewrite it as prime numbers. So like, yes. So let's do 16. 16 is going to be 2 to the 4th. So let's rewrite it as a 2 because that's a prime base. 2 to the 4th, that's 16. And that's being raised to a 2/3. And then on the denominator, I have 4 to the 1/6. So instead of putting a 4, write it as a prime base, so 2 squared to the 1/6. I'll give you a minute to write that down. But the goal of these is to always rewrite your base as a prime number, like 2, 3, 5, 7, or sometimes 6. Rewrite it as a prime number, and then you can apply the rules of exponents. So number 4, the numerator, I need to multiply the exponent of 4 times 2/3, because that's what the rule says. So 4 times 2/3, 8/3. On the denominator, same thing. I need to multiply 2 times a 1/6. So that's 2/6, but let me write it as 1/3. And then finally, we need to apply the rules of exponents to simplify it. When you divide bases like that, you're supposed to subtract the exponents. First of all, remember, the base will stay the same. It's going to be a 2. And now you subtract 8/3 minus 1/3. 7/3. And I guess we just keep working on these. Always rewrite the bases as prime numbers. So number 5. I see a 32 there. You need to recognize it as 2 to the 5th. Just like I told you on, like, I don't know, one of the lessons, that's a perfect perfect quintic. So 2 to the 5th. That's being raised to a 1/3. On the denominator, I already have a prime number of 2 raised to the 1/4. The entire thing is being squared. So let's go ahead and work on the inside of the parentheses first, and then we can do the squaring thing. So let me work on the inside of the parentheses first. 5 times 1/3, that's going to become 5/3. So I guess I can just write it down and show my work. So that's going to become, I don't know why I wrote a 5 there. That's 2 to the 5/3 over 2 to the 1/4, all of that squared. And now rules of exponents say to, when you're dividing, I need you to subtract the exponent. So subtract 5/3 minus 1/4. If you forgot how to do fractions, we might have to review the fractions, but we need a common denominator. So probably 12. So 20 12s. 4 times 3 is 12. Yep. And 3 12s. So now I can subtract 20 12s minus 3 12s and get 17 12s. So I have 2 raised to the 17 12s. Because I subtracted 20 12s minus 3 12s. But then don't forget that you're still squaring that. So final answer is just multiply the 17 12ths times a 2. And one thing you can do here is you can reduce that to a 1 and that to a 6. So number 5, your answer should be 2 raised to the 17 sixths. So in order for you to be successful with this lesson, you definitely need to practice, review the rules of exponent, and then also review how to like add, subtract, and multiply fractions. Okay, number 6. This one's a little crazy here, but okay, so what I'm going to do is I'm going to first write the bases as prime numbers. So instead of writing 81, you need to recognize that as a quartic of 3 to the 4th. So 3 to the 4th, that's 81. Okay, now that's being cube rooted. So instead of writing it as a cube root, I'm going to write it as a fractional exponent, and that's what we did on Tuesday. Or like on the do now, I showed you that formula. Where'd it go? Yeah, this formula here. So when you have like the cube root of x, that just becomes x to the 1/3. So that's what I'm doing here. Same thing with the 4th root. I need to take this entire thing and take the 4th root, which means just write it as a 1/4. And finally, there is a cubic right there. So yeah, this one was crazy complicated like that. And now we're going to divide. So let me just go ahead and put it on the denominator since it's a division sign. Do the same thing again. Rewrite 27 as a prime base. 3 cubed. If I do something wrong, someone just stop me. Take the square root of 27. So instead of taking the square root, write that as a 1/2, because that's what fractional exponents do. It's a 1/2. Finally, we're going to take the cube root of this whole thing, or in other words, raise it to the 1/3. So these are the kind of questions that we normally do in class, and what you normally see on the test and quiz, but this year they'll be a lot simpler than that. All right, now you simplify it. So to simplify it, you apply the rules of exponents. So the first rule I'm going to apply is when you have an exponent raised to like another exponent, you're supposed to just multiply. So right here, all these things, you're going to multiply 4 times 1/3 times 1/4 times 3. So it should not just be 1 because 4 times 1/4 is 1. 3 times 1/3 is 1. So it looks like this whole thing just becomes 3 to the 1. And then the denominator becomes 3 times 1/2 times 1/3 becomes 1/2 because the 3 and the 3rd cancel out. So I have 3 to the 1/2. And then finally, the last step is to subtract the exponents because you're dividing here. So you should have 3. 1 minus 1/2 is to the 1/2. The answer key is wrong. If you're looking at the answer key, somehow I left the answer key as the square root of 3. That's wrong. Technically it's equivalent, but the question says to do it in exponential form. So leave it as 3 to the 1/2. On your test and on your quiz, it will tell you like leave it in exponential form, so write it like that, 3 to the 1/2. Or if it says leave it in radical form, then you can leave it as the square root of 3. Just make sure you follow the directions or it'll be counted wrong. So number 6, the answer is 3 raised to the 1/2 because I subtracted 1 minus 1/2. Okay. And now let's just keep practicing a little bit more. 3 more questions and then we can just practice the rest of the time. Okay, same thing. Apply the rules of exponents to simplify. This time, however, we're going to leave our answers in radical form. All right. Number 7. Always write the bases as prime numbers. So instead of writing 32, you should write 2 to the 5th. Because that's 32. And that is raised to a 1/6. And now you have 8, so write that as 2 to the 3rd. And that is raised to a 1/4. Okay, now apply the rules of exponents and multiply 5 times 1/6, multiply 3 times 1/4, and then we're going to add them together. So 5 times the 6 is 5/6. 3 times the 4th is 3/4. And finally, like I said, you add the 5/6 plus the 3/4. To add fractions, you have to find a common denominator. So 12 times 2, so 10 twelfths. And then times 3, 9 twelfths. Now you can go ahead and add the exponents. So my answer should be 2 to the 19 twelfths. If the question wants exponential form, that would be your answer. You would box that. Like on the top, we did exponential form. However, here it says to do it in radical form. So now, again, like what we did on Thursday or that formula that I showed you here on the do now, go ahead and write your exponential form as a radical form and rewrite that as the 12th root of 2 to the 19th. That's your radical form. But just like we did on the lesson on Tuesday, I told you to always make sure, or I don't know if I said it, but when you have a radical, your index root has to be bigger than the exponents inside. If it's not, then that means that it's not simplified. And that's because like this index root 12, that can go into 19 once. So we do need to simplify that. 12 goes into 19 one whole time, so that means that you would take a 2 to the first power out, and there would be a remainder of 7, because when you go 12 into 19, that's only 12, and then the remainder is 7, so you write it as 2 to the 7th. So number 7, final answer should be 2 times the 12th root of 2 to the 7th. When you're testing quiz, you can leave the 2 to the 7th like that because I don't expect you to know that one, even though that's not too bad. If it's a big exponent, you can just leave it like that. But if it's a small exponent, like 2 to the 3rd, make sure you write it. That's number 7.
One question.
Yes, question?
Do you have to like write 2 to the exponent of 1, or can you just like 2?
Just put 2. I prefer if it's just 2. Either one's correct.
Okay,
so that was number 7. Let's keep practicing. 243. That was probably one of those cubics that I gave you. I don't remember, but 243 is pretty big, so let me divide it by probably 3. 3 times 81. So I guess 243 is a quintic. 3 to the 5th. Yeah. So I'm taking the 243, and remember, you always have to rewrite your bases as prime numbers. So, even though I don't even think you need it, no, you probably do. So I'm just going to write it as 243 is going to be written as 3 to the 5th because 243 is 3 times 81, and 81 you should definitely know that's 3 to the 4th. Okay, so that's being raised to a 2/15 times x to the 2/6. Should I just do 1/3? I'm gonna reduce the 2/6 to a 1/3. Hopefully I won't regret it. 9 should be written as 3 squared. Raised to a 1/6. And then x, let's divide that by 2. 8 over 12. 4/6? No. By 4. Divided by 4. 2/3. 4 times 3 is 12. 4 times 2 is 8. Yeah. So all I'm doing is step 1. Rewrite the bases as prime bases. So 3 to the 5th and 3 squared. Now apply all the rules of exponents. So right here I'm going to multiply 5 times 2/15. And that's going to reduce to, I guess, that the 5 and the 15, that should just reduce to 1 and 3. So I have 3 to the 2/3 times x. I guess let me just add the x to the 1/3 with the x to the 2/3. I'm just going to add them together, and that's just x to the first. And you don't have to put the first right there. Finally, this is 3 to the 1/3. Yeah, it's a 1/3 because 2 and 6 reduce. So final answer, I can add this 2/3 with this 1/3 because those are a base of 3. Okay, so after all that craziness, the answer is just 3x. And I don't know why I switched colors here, but so that's the final answer, 3x. If you have any questions, let me know. We got one last problem to do, and then we can just practice, I guess, or answer questions. Last one, number 9. Apply the rules of exponents. So we're going to have to just subtract 2/3 minus 5/6, which have to have a common denominator. So let's change this to 4/6 times 2 times 2. Yeah, 4/6. So then when I subtract x to the 4/6 divided by x to the 5/6, that's going to give me x to the negative 1/6. Yeah, 4/6 minus 5/6 is negative 1/6. And then remember I told you, when it comes to all the rules of exponents, your exponent has to be positive. So to make this positive, you just apply the rule here that says when you have negative exponents, you can make them positive by moving them to a denominator. You put 1 over. So that's what I'm going to do in number 9. I'm going to write that as I'm going to write this as 1 over x to the 1/6. So this is called exponential form, but you need to give me the answer in radical form. So that means that we need to write that as 1 over the 6th root of x, because that's what we learned on Tuesday with the formula. If you have x to the 1/6, that's the same thing as the 6th root of x. And then on Tuesday, I taught the class how to rationalize fractions that have roots like the 5th root or 4th root or 3rd root, like this one. So I guess if you were here or if you did do the notes, try to see how you're going to rationalize the denominator. And here's what I said earlier. If you have a 6th root, then you want this denominator to be, I don't even know what it's like. You want the denominator to be a multiple of 6. So the exponent, you want the exponent to be a multiple of 6. Right now, my exponent is just x to the 1st. So what I'm going to do is I'm going to multiply by x to the 5th. Or actually, the 6th root of x to the 5th. The reason why you want to multiply by the 6th root of x to the 5th is because when you multiply that times x to the 1st, this is going to become, that's going to become the 6th root of x to the 6th. Because remember, you're adding the exponents 5 plus 1. And therefore, that would just become regular x. This is just x. So then final answer, on the numerator, you just have 1 times the 6th root of x to the 5th. And then on the denominator, you have what I just went over. When you multiply that and you simplify it, you end up with regular x. And you are done with the problem. Let me stop my video before I forget. And then I'll just answer any questions. So go practice.